Hey guys, this time we're going to look at some titration calculations. We're just going to go through a simple titration calculation first, where we're looking at calculating the concentration and the mass of an unknown solution. Okay, so the problem is we've got a 25 milliliter sample of sodium carbonate in a conical flask. Okay, the sample was titrated with a 0.2 mole per litre hydrochloric acid sample, which is in our burette over here, and 23.2 mils of that hydrochloric acid was required to reach the endpoint of our titration. Okay, and our goal is to calculate the concentration in moles per litre of our sodium carbonate first, and then we're going to use that value to calculate the mass of sodium carbonate in our 25 ml sample. Okay, so the first thing we're going to do is write a balanced chemical equation. Okay, so we're adding hydrochloric acid to sodium carbonate, acid-base reaction, acid-base carbonate reaction. We're always going to get a salt, carbon dioxide and water. Okay. To balance that, we just need to balance our sodiums. We've got 2 there, so we need 2 there. And now we've got 2 chlorines, so we need to balance our chlorines on this side, and everything else should be fine. Okay, so first step for calculating the concentration in moles per litre of our unknown solution is that we need to calculate the number of moles of our known solution that we've got. Alright, so we're going to deal with hydrochloric acid first. Okay, so what do we know about hydrochloric acid? We know that we've got 0.2 moles per litre, so that's our concentration. And we also know that we use 23.2 mils, so that's our volume. Remember, volume must be in litres, so 0.0232 litres. Okay, just fix this. Okay, we want to find moles. So the formula for moles, remember, is concentration times volume. Okay, very simply, 0.2 multiplied by 0.0232, 4.64 times 10 to the negative 3 moles. Okay, that's for our hydrochloric acid. Now we want to calculate the number of moles of sodium carbonate so that we can then calculate the concentration. Okay, so the way that we're going to do this is by using our reacting mole ratio, okay, which we get from our chemical equation. If we have a look at our chemical equation, we've got 2 hydrochloric acids and 1 sodium carbonate. So our reacting mole ratio is 2 parts to 1 part in favour of HCl. Okay, so when finding the number of moles of our unknown, we need to multiply by our reacting mole ratio. Okay, so if we look here, we've got 2 parts HCl, 1 part sodium carbonate, so we've essentially got half the amount of sodium carbonate. Okay, so what we're going to do, we're going to say to find the number of moles of sodium carbonate, right, we need to do 1/2 times the number of moles of HCl. Okay, which is going to give us 1/2 times this number here, 4.64 times 10 to the negative 3, 4.64. 2.32 times 10 to the negative 3. Okay, that's our number of moles of sodium carbonate. Okay, to calculate our concentration, sodium carbonate, right, we need to use our number of moles. And we also need to use our volume, okay? From the question, we've got a 25 ml sample, okay? 0.025 litres. Right, now our concentration formula, C equals N divided by V. Okay, we're simply just going to divide N by V here. So 2.32 by 10 to the negative 3 divided by 0.025. And that gives us 0.0928 moles per litre. Okay, so that's our concentration of sodium carbonate in our original 25 ml sample. So as you can see, this is a little bit of a process. First step, calculate the number of moles of your known solution. Second step, find your reacting mole ratio. Third step, multiply your reacting mole ratio by your number of known moles. That'll give you a number of unknown moles. Then use that along with your volume to calculate the concentration of your unknown solution. Okay, now we need to do part 2, which is to calculate the mass of sodium carbonate in our sample. Okay, so in order to calculate the mass, we need the number of moles and the molar mass. Number of moles we've already calculated, 2.32 times 10 to the negative 3. And the molar mass for sodium carbonate, which you can calculate from the periodic table, is roughly 106 grams per mole. But that's just a rough estimate. Okay, you can figure out that using your periodic table. Right, our formula for mass is N multiplied by big M. Very simply, 2.32 by 10 to the negative 3 times 106. And this gives us 0.246 grams. So very easy to find the mass. We just multiply the number of moles by the mole mass. 2.32 times 10 to the negative 3 by 106 gives us a mass of 0.246 grams of sodium carbonate. Okay, this is a rather simple titration calculation. Next time we'll try something a little bit more challenging.